So hello everyone, in this video we'll be solving another LeetCode problem, and the problem name is longest strictly increasing subsequence with non-zero bitwise end. So you are given an integer array nums, return the length of the longest strictly increasing subsequence in nums whose bitwise end is non-zero, and if no such subsequence exists you need to return 0. And then they have given the definition that a subsequence is a non-empty array that can be derived from any other array by deleting some elements or no elements without changing the relative order. So what the question is saying that you need to find the longest increasing subsequence whose bitwise end is non-zero. So this is what the question is saying. So let's say there are few elements. Let's say there are elements, let's say 1, 2, 3, 4 and 5. So in this you need to find the longest increasing subsequence. So let's say we take these elements such that their bitwise end is non-zero. So this is what the question is saying. So we need to find the longest increasing subsequence, or we need to return the length of the longest increasing subsequence. So how we can solve this problem? So we need to select few elements such that their end value should be non-zero. First is this condition, then we will find the LIS, right? So there is one property of end. So what is the property of end? Let's say you have some set of values already. You have taken their end values. Now if you add more elements to this set, if you add more elements of this into this set, either that their end value will remain same, or their end value will decrease. It will never increase. So this is one special property of end, because even if in one number the set bit is 0 and in all the other numbers the set bit is 1, then also the resultant set bit will be 0. Then the resultant bit will be 0 in this place. So let's say this is some position ith. So you have one number, you have two number, you have three number, you have four numbers. So at this ith positions you have three elements whose ith position has set bit, and there is one element whose ith bit is not set. So if you take the end, it doesn't matter how many ones you have. Even if you have 1 0, it will make that ith position in the resultant to be 0. So even if there is one bit 0 in the number, it will make the entire resultant and for that ith position to be 0. So we don't have to care about what is the value of end. We just need that end value should be non-zero. So what we can do? We can say we need at least this ith bit set. We need at least one bit set in the entire nums array such that we can include as max elements as possible. So even if one bit is set, let's say we are at 0th bit, so in the entire nums array, if each and every value has this 0th bit set, that means the end value will be non-zero, because in the resultant we will have one set bit, and if there is one set bit, then the answer will be non-zero. It will be always greater than 0. So what we can do? We need at least one bit set. So what we can do? We will have 32 bits in total. If you see the range, I think it is 10 raised to the power 9. In the integer range, the value is 10 raised to the power 9. So that means we will have 32 set bits. So we need at least one bit set. So what set bit we will choose? No problem. This 32 is a very small number. So we can check from 0 to 32. We can check for each and every set bit. We can check for each and every ith bit. So for the ith bit, what all values of nums are there whose ith bit is set? So let me just show you in more better way. So what all values in nums? Let's say this is the value nums. This is the array nums and it has some value. Let's say we have this element, this element, this element and this element has the ith bit set. So we can say okay, these are the four elements whose ith bit is set. Now these are the set of elements in which we need to find the longest increasing subsequence. So for each and every I value we can say what all elements has this ith bit set, and for those ith bit we can find the longest increasing subsequence. So this is what we will do. And how will we find the longest increasing subsequence? Let me show you. So let's say the four numbers that we have said that are 1, 100, 2 and 3. So let's say these are the 4 numbers that whose ith bit is set. So these are the 4 numbers. So in this we need to find the longest increasing subsequence. So this is the first number. So we will put an array which will consist of all the longest increasing subsequence, the elements of the LIS basically. So this one is the first number that will be in the LIS. So if the array is empty, we will just push the first element inside it. Now the next element is 100. So we will check whether the last element is less than this current element or not. So yes, last element is lesser than this current element. So we will push this 100 into our this array. So you can see there is a increasing pattern. There is 1, then there is 100. Then we come across this number. This is 2. Now you see the last element is 100 and the current element is 2. So last element is greater than 2. That means if we put 2, it will not be LIS anymore. It will start to decrease. So we don't want this element, or we need to place it in somewhere such that our LIS doesn't break. So what we can do? We can replace this 2 with the highest value possible. So what we can do? We can replace this 2 with the value which is just greater than or equal to 2. Why? So let's say it is 100. It is 100, right? So let's say we replace this 100 with 2. So our LIS length doesn't change. But what will happen in future? If this 3 comes, we can accommodate 3 also in the LIS array. But what if we haven't replaced it with 2? So if it was 100, so we can't put 2 and we can't even put 3, because even if we put 3, it will be start in decreasing order. So what we need to do? We need to replace the number. We need to replace this number with the number which is just greater than or equal to this number 2. So what we will do? We need to search in this array. So we will search in this array what is the number x which is just greater than or equal to this current number 2. So if we will replace this with number, it will create a chance that our LIS length will increase. It will not affect the current length. The current length will remain same because we are replacing it with some element that is already present in the array. So length will remain same for now, but it will create a possibility that in future we can add more elements. So you have seen, if we have 100, we can't put any other elements in the future, but if we have 2, we can put 3 also in the future. So this is what we will do. So in the end, whatever this length of this array will be, we will just take that length as the LIS. So res.length, let's say this array name is res. So res.length will be the length of the LIS, and we will do it for each and every ith bit. So let's say for ith bit our LIS is 6, for some other ith bit our LIS is 8. So we will keep on comparing and get the maximum answer. So I hope you understand this solution. Let us see the code now. So you can see this is the code. So first n is the size of the nums array, and we are taking the maxi which is 0. This maxi is nothing but the longest increasing subsequence whose end is non-zero. So for that, what we are doing, first we are iterating on all the 32 bits possible. From 0 to 31 we are iterating, and we are creating a vector v which will keep track of what all elements are present in nums whose ith bit is set. So this will check if nums of j has the ith bit set, then push it into this vector v, and we will take all the elements of nums whose ith bit is set. After that, we will get an array whose ith bit is set. So these will be the numbers. Now within these numbers we need to find what is the LIS. What is the LIS of this array? So we will call the function LIS, which will take this vector v and give us the LIS for this vector v. So let's see what we are doing in this LIS. So we are creating a array res which will give us the LIS array, which will only have the elements in increasing order. So it will give us the basically longest increasing subsequence. So in this we are just iterating onto this entire vector v. So we will check whether the res is empty or not. If it is empty, that means this is the first element, so we can just push this first element. And when we will push the element, if the current element is greater than the last element, if the current element is greater than the last element, that means this is an increasing sequence. So we will push that current element into our res vector. Otherwise, what we need to do, we need to replace this current element with the element x, which is just greater than or equal to this current element. So we are just finding with the help of lower bound. So we are just searching what is the number which is just greater than or equal to this current number v of I, and we will just replace that number with this v of I. In the end, after doing this entire operations, entire iteration, we will just take whatever is the length of this res array. This will give us the length of the longest increasing subsequence. So this will give us the length, and whatever is the current maximum length that we have till now, we will just compare it with that. So if this length is greater than the current maximum, so we will replace that current maximum with this particular answer length. So it will keep on doing for each and every bit from 0 to 31, and in the end, whatever is the maximum length of LIS, we will just return that. So I hope you understand this solution. Thank you for watching.